Yeah, hello everyone. So I've been working on my engine here of my 1981 DeLorean. I've just been going through the fuel system here, just doing a bunch of checks on pressures and so on. I have a bit of a kind of a rough idle as the car warms up, so I was trying to diagnose what may be going on here. So currently, you can see I have all the injectors pulled out. The air filter is off the car. I've also removed the electronic idle valve there to make it easier to get the injector out. So that's why the engine looks like it does right now with the injectors pulled out. I've also got my K Jet fuel pressure gauge connected here, but I'll talk about this a little bit later on how I've got it hooked up and what I'll be testing with it. But before I get into some of the tests and looking at the spray from all the injectors, I wanted to just go through a little bit of basics here with regards to the fuel system. Try to give a little tutorial and go through what I've learned doing this and reading up on it. So the DeLorean, the 2.8 liter V6 PRV engine uses Bosch K Jet fuel injection. It's actually K Jet with lambda control. But CIS, of course, is continuous injection system, and K-Jet, the K is the letter comes from the German word continuous, which is spelled with a K. So that's where the name comes from. It's part of the Bosch Jetronic family, and there were several versions over the years. Like I said, the DeLorean uses the K-Jetronic with lambda control, and that can be identified kind of in two ways. All K-Jet systems, basic and lambda, both use a fuel metering unit, which is this device right here that's usually painted black and is made from cast iron. And the later versions, which are electronically controlled, are usually made from aluminum. You can also tell by the frequency valve right here. This electronically controlled valve is part of the lambda control system. That's an add-on and a later improvement to the system to help control. I'll get into control of the system a little later on, but perhaps in another video. But for this video, I want to just talk about some basics of how this system functions. So first of all, being that the system is called continuous injection system, it literally means that. That means whenever the engine is running, there's fuel flowing from the injectors into the engine. And the injectors reside in the intake path before the valve. So whenever the engine's running, all injectors are spraying fuel at the same time. It's not a pulsed system. It's not opening and closing based on the position of the piston. There's fuel flowing all the time when the engine's running. And if it happens to be that a valve is closed when the injector's spraying, that air just gets in the intake path before the valve, and then when the valve opens, it gets sucked into the engine. So fuel is controlled by the amount of fuel that goes into each piston, or each cylinder really, is controlled by the metering unit, which is the heart of the CIS system. This black cast iron piece that has all the injection lines connected to it. And you'll see on this car here, these are the 6 lines. This is a 6-cylinder engine going to the injectors. You also have the return line, which is this one here, which goes back to the fuel tank. There's another line that comes around the back. Also this silver braided one, that's the fuel from the pump. So that's the feed line. In line ahead of that is the filter, and then the fuel accumulator, and then the pump, which is mounted in the fuel tank. You've also got a cold start injector for cold starting, this line off the side, and this line here off the top down to the control pressure regulator on the side, and its return line back to the metering unit. You've also got 2 fuel lines that go, of course, to the the frequency valve on the side here. So basically, the system regulates the amount of fuel that goes into the engine based on a certain amount of air. So air-fuel mixture, of course. And the fuel amount is controlled mechanically by a given amount of air. So this plate here, which normally the air filter is sitting on top of, the air is coming downward into this section here. Some cars have it the other way around. There's two versions of this. You can either have a downward flow or upward flow. I think if you look at a 80s Volkswagen Golf or GTI, the air flows the other way around. The filter's below the unit. But on the DeLorean PRV engine, the airflow is downward. So this pushes this plate down like that. And you can see it's very easy for me to push this down right now because there's no fuel pressure currently. And I'll get into why that is the case later on. So for a given amount of air being sucked into the engine, that plate deflects. That's like on a teeter-totter inside. There's a mechanical linkage there. And inside the center of this fuel metering unit is a highly machined piston that rides up and down. So when the plate goes down, that piston goes up. So inside the fuel metering unit, it's basically divided in two parts. You have the lower section and an upper section. The lower section is where primary or system fuel pressure is coming. So you have full pressure from the pump coming into the lower section of the metering unit. And then that pressure is then regulated by a pressure valve, or primary pressure valve, sometimes called a PPR. And that is this device right here. This kind of bolt or screw that's threads inside the body here, and inside that it's got a bunch of springs and seals and so on. And basically that valve is normally closed, and when you crank the car and the pump starts to run, the fuel starts to flow, and the pressure builds until it reaches a prescribed amount. And for these engines it's about 75 psi. Once the fuel pressure increases enough to overcome the tension of the spring holding that valve closed, that valve will start to open, and it'll regulate the pressure at 75 psi going into the lower half of the metering unit. Any excess pressure or fuel is then sent back to the tank via the return line. So that valve is kind of critical as it regulates the system pressure. And in CIS, fuel pressure is key. It's very important because it's pressure that opens and closes the injectors. There's no other means of opening and closing the injectors. So the fuel metering unit, based on a given amount of airflow, the more this goes down, the more the plunger in the center moves up, and the more fuel is allowed to flow out to the injectors. So back to the metering unit. Inside there, again, on the lower half is where primary fuel pressure resides. And when the airflow plate is pushed down by airflow, there's a plunger in the middle that moves up. And when that moves up, it allows high pressure fuel to follow a path to the upper section of the fuel metering unit where the injection lines are connected. So that's the path fuel takes to get from the lower to the upper chamber and then out to the injectors. So the way that's controlled is there's basically a tube or a barrel that has really finely machined little slits. In this case there would be 6 of them because this is a 6-cylinder distributor and a 6-cylinder engine, and there is a line with each injector port. So that tube has these 6 slits in it all the way around, and the plunger rides inside that tube. And as the plunger moves up, it allows fuel to flow from top to bottom. Now, because it's all pressure related, the pressure difference between the upper and the lower chamber is critical to actually open and send fuel out. It doesn't go directly to the injectors. There's a differential valve between them, one on each injector feed. These little individual differential valves regulate and maintain the pressure difference regardless of the amount of fuel being flowed. So in this video I want to talk about some of the control systems that are part of the CIS K Jet fuel injection system. So as I described in the prior video, the basic function of the fuel metering unit in relation to the movement of the airflow plate. Basically, as air goes into the engine, it pushes this plate down. That's on a teeter-totter lever that in this case, raises the plunger that's in the center of the fuel metering unit up, which exposes inside there more of the slits in the barrel, which allows more fuel to flow. So the more this deflects, the more the plunger rises, the more the slits are exposed, and the more fuel can flow through the slit and into the differential valve and then out to the injector. Now, some of you may have in the past on your cars adjusted for fuel mixture by removing the plug here, or this little pin thing, a little plug, and in there is your 3mm Allen screw that you turn clockwise or counterclockwise to adjust your fuel mixture. What that's actually doing is a mechanical adjustment between the relationship of the position of this plate and the position of the plunger that's inside here. So with the plate at rest like it is now, if I was to screw this clockwise, it would raise the plunger slightly. If I was to go counterclockwise, it would lower the plunger slightly. So you're setting a basic fuel mixture relationship between airflow and fuel flow. Now I know you've done that probably with a meter connected to monitor using the dwell gauge to monitor the frequency valve. That's part of the control systems, but that mechanical adjustment is basically what you're doing. It's a relationship adjustment between the air and fuel, the airflow physical valve flap here and the plunger inside. So now I'll talk a little bit about one of the control systems on these engines, and that is with regards to control pressure. So I already talked about system pressure, which is your primary pressure that's coming in from the pump and regulated by the pressure valve here and exists in the lower chambers all the time. Control pressure is a secondary system that is managed and controlled by the control pressure regulator, which is this device right here. Some of you may call that a whir or a warm-up regulator. That's kind of its older term when on older designs where the warm-up regulator was its sole purpose, was just to control the warm-up cycle of the engine. But on these cars, that device has a couple other functions, so it's more appropriately called a control pressure regulator. So, and what control pressure is a way for the system to adjust air-fuel mixture as the engine warms up. So, a cold engine, by nature, in order to run smoothly, needs a more rich mixture than a warm engine does. So that's a adjustment that needs to happen automatically. So the way the control pressure control system works to regulate air-fuel mixture during warm-up is to vary the amount of distance the plunger that's in the center of the fuel metering unit can move for a given amount of airflow volume. So before in my description about how this works, that was a fixed relationship. What I didn't touch on was that control pressure is a hydraulic system pressure that opposes the movement of the plunger. So right now there's no system pressure in the car because I haven't run the pump, so there's no pressure here. This is easy to move. If I had fuel pressure in, this would be harder to move because it would be a opposed from moving by the force of control pressure. So the way the system functions is like this, is basically high pressure fuel from the primary side, system pressure side, which comes from the bottom half of the fuel metering unit. Inside this, there's a very small passageway for high pressure fuel from the bottom to reach the top, and for this connection here, and also down into the center to the top of the plunger. And that's a very finely machined restriction passageway so that only enough pressure gets down there. The fuel line here, which is the takeoff, which goes to the control pressure regulator on the side. Now I have it hooked up to my pressure gauge right now, so I'll show you how I have that connected. So this is a CIS K Jet pressure gauge, and that consists of basically a Y. There's a hose this way and a hose this way, and then the gauge hose here, and then this valve. So this side, the side of the gauge that doesn't have the valve, connects to the fuel line, which is coming from the top of the fuel metering unit using the banjo bolts and new washers and this adapter. So that feeds the gauge here. On the other side, that side that has the valve, that goes around and connects directly to the control pressure regulator, where this line normally would reside. So this is where the larger of the two banjo bolts would be. So that's the inlet side of the control pressure regulator. So that's how I have my gauge. So basically, fuel comes from the top of the metering unit at high pressure and is routed to the control pressure regulator, and then the other connection goes back to the fuel metering unit on the return to tank side. It actually goes into the pressure valve, but it basically goes back to tank. And what the regulator is doing is varying the amount of pressure that's being applied to the top of the piston by bleeding off fuel back to the tank. So the more fuel it bleeds off, the lower the pressure is resulting in the top of this, which means the plunger can move easily. So there'll be less force here. And that's the case when the car is cold. So the control pressure regulator adjusts pressure based on temperature. So it usually starts off for a cold car around 1 bar or 1.5 bar depending on temperature, and then goes up from there all the way up to 50 psi or so, or something like that. So when it's cold, it's a bimetallic arm in there that operates a pressure valve basically, and the more that valve is open, the more fuel is burned off to the, or not burned off, but released back to the tank, which lowers the fuel pressure in the top of the plunger, which allows it to move easily, which means more rich. So as the car warms up, that pressure starts to increase, the device starts to warm up, closing the valve, which means less fuel is getting bled off to the tank, resulting in higher pressure at the top of the plunger, which in turn increases the amount of force it takes to push this plate down, and thereby how much force it increases the force it takes to push the plunger up, because remember, these two are connected. Okay, so the higher the fuel pressure is coming from the warm-up from the control pressure regulator, results in a leaner mixture. So that's the situation you have when the car is warm. So for a given amount of air flow, when the car is cold, this plate will move a lot, which means the mixture will result in being rich. And for the same amount of air, when the car is warm, the pressure in here is higher. This plate will move less and be a leaner mixture. So that's how control pressure affects the warm-up cycle of the engine. So on its own, the control pressure regulator, as far as its heat-up cycle, which thereby then affects the valve, which affects the fuel pressure, the control pressure, it gets heat obviously from the engine as the engine heats up, percolating through the valve cover and into the body of the control pressure regulator itself, which then affects the bimetallic arm inside to move. But that process can take, up to 10 minutes or more, depending on the ambient temperature of the air. So to enable that to go quicker, because that might be too long for cold start fuel enrichment, a richer mixture, the warm-up regulator has a connection, an electrical connection, right here, which is a heater circuit. So that gets power from the RPM relay, and when you are running the car, when it's cold, that gets powered, and that'll actually heat up the control pressure regulator bimetallic strip inside faster, about a minute to 2 minutes, instead of the 10 minutes it takes for the car to heat up on its own. So that's what the electrical connection does. So it takes, I've done this on this engine from roughly 55 degrees Fahrenheit ambient temperature. It takes about 2 to 3 minutes for control pressure to go from its lowest setting to its highest setting around 51 psi after a cold start scenario. You may also have noticed that on the control pressure regulator that's used on a DeLorean, it has vacuum connections as well, and a delay valve on connecting one side to the other, and that's fed by a vacuum switch underneath the intake on the Y pipe, which is in turn fed by a port connection on the back of the intake here. So when you step on the gas, the vacuum activates the valve here, activates the valve just for a moment, enriching the fuel mixture for a moment. And that only lasts for less than 10 seconds, and then it should return to normal again by the delay valve. Now that system only will function when coolant temperature is below 104 degrees Fahrenheit, and that's the function of the switch below. It's the green one with the 3 prongs on it. That directs the intake vacuum to the control pressure regulator when it's cold, and when it's warm it goes to the distributor advance. So it's a switch in there, but that only functions when the car's cold. So in the next video I'll talk about the other K Jet Lambda control system, which is the Lambda system, the ECU, and the frequency valve, and how it affects fuel mixture and how it affects pressures inside the metering unit. So now I'm going to go ahead and test my pressures, fuel pressures here, control pressure and system pressure, and also look at my fuel injector spray. So this is something I've been working on now for a while. I changed a couple injectors, and because they seem to have been dripping after the system was turned off. So I got the injectors all out, I got them all in the bottles here, and I got the bottles numbered. So when I take them out later, I can identify which cylinder each bottle was from when I put them on the bench. So I got my gauge connected here, I got my temperature gauge. So the first thing I'm going to do is measure the temperature of the warm-up regulator, or the control pressure regulator, sorry. And I'm getting basically 60 degrees. So I'm going to go ahead and turn on my fuel pump, and I've jumpered it, and I've wired it to this switch here so I can easily turn it on and off. So I'll go ahead and turn it on, and you can hear the fuel flowing now and returning back to the tank that's not being used, and I can read my control pressure. So at 60 degrees it's still a bit low. This is one of the things I'm trying to work on here. So I'm reading control pressure now because I have the valve open. So fuel is flowing from the top of the regulator through the gauge to the regulator and back to the tank. If I close this valve now, this should go up. So So this goes up to about 68 psi. Now, of course, this is based on the performance of the fuel pump. I haven't run the car in several weeks, so the battery may be low a little bit. I think I was getting about 12.2 volts. So these numbers would probably be a little bit higher if I was running the car. So I'm going to switch this back to control pressure now. This is... So now I can hear fuel flowing through the system. The gauge is dropped back down. So as I described in my prior video, now that I have control pressure, I should feel a force on this plate when I push it down. Now when I do that, this system is going to function, fuel will flow through the metering unit into the injectors. So that's why I have them in all these bottles now. And because the injectors are outside of the intake, they're not buried in the intake anymore, you're going to hear them. They're actually quite loud. They kind of squeal. And that's the sound of them opening and flowing fuel. So I'm just going to give this a little quick spray there. So there's some force there now, and you can see it returns back up quickly. That's the control pressure force pushing down on the top of the plunger, which is pushing this back up. So I just want to make sure my bottles, my injectors all stayed in my bottles, and it looks like they have. So I'm going to go ahead and give this a, I'll run this for a little bit so I get a half an inch or so of fuel in each bottle. So I give it full throttle. It's quite loud. You can see the fuel spraying there. So you can see this is how it would be if I was cruising down the street at 30 miles an hour, air flowing through, nice and consistent. I got fuel flowing on all 6 injectors all at the same time, equal amounts of fuel. Well, should be equal amounts of fuel anyways, going to each injector as I'm driving along. Another thing control pressure does is stabilizes the movement of this plate. You can imagine if it was loose, it may flop around, varying airflow. This smooths things out nicely when the engine's running. All right, so now I'm going to separate the bottles here and put them on the bench, and we can take a look at the level. All right, so I've done my field test, and here's the bottles pulled out. Actually, this is like the second time I did this bottle test. Actually, after the last video, I pulled the bottles out and looked at the values, the amounts actually, and forgot to record the video. But prior to that field test in the last video, I had actually, so here's my little calculations, I had actually changed injectors 2, 4, and 5 prior to that test. And I found that, well, here, let's look at the results in this first. So I got the bottles lined up. I got them numbered here in order, and you can see the fuel levels inside. So just looking by eye, just right now 3, 4, 5, and 6 are all pretty close. Number 2 is the worst offender, and this is after this test. But this is what I did. So before, I had changed injectors 2, 4, and 5, and then I did this fuel test. And instead of looking at the levels, I did weights in grams. So I borrowed my wife's kitchen scale here, and I did a weight measurement in grams of the bottles. Since the bottles are all the same, they're all like crystal geyser bottles. And this is what I got. So this is the weight of the bottle with the fuel in it after the first test, after I had changed out injectors 2, 4, and 5 with new ones. So you can see I got quite a range here. This is 6 is the highest flowing and 2 is the lowest. So that's the worst offender in my opinion. Even though that's a new injector, it flowed pretty low. So I was curious about that, whether or not that was a port on the distributor, or whether that was actually the injector causing that issue. So just for comparison here, I looked at my totals per each bank. So cylinders 1, 2, 3, and then cylinders 4, 5, 6. I added them up, and this is what I got: 180 grams and 192.5 grams for a difference of 18.5 side to side, which is quite a bit. I actually poured the bottles all together, and I got, you know, that much liquid that was difference from one side to the other. So big variance, and more than 10% across the 6 injectors. So that wasn't very good. So for this test, I actually I took out number 3, and I changed that to a new one. So 3 was another low flow injector at 60 compared with the others. And I took what was cylinder 6 and I swapped it with position 1. And I wanted to do that so position 1 was 60.5 and position 6 was... I wanted to see if the high fuel rate stayed at 6 or whether it moved to 1. If it moved to 1, then the injector was flowing and not the you know, it wasn't the fuel metering unit that was unvarying. So this is my result after, and well, it's not super conclusive. Cylinder injector at 6 went to position 1. Now you can't compare the numbers from the left side to the right side because I didn't, you know, didn't necessarily flow the same amounts of fuel, but pretty close. So these are my values now, and as you saw when I showed you the bottles, number 2 was the you know, the lowest flow, and by the weights it's the same. 57.5 is the lowest. 1 is still a bit low, and these all came up a bit. So number 3, let me just turn this on here, let it 0. Number 3, 66.5. So I had written 67.5 before, so that's the highest flowing now. And that's a new injector. So I also did my additions, left bank and right bank, 186.5 for these and 190.5 for these. So this side came down. Now I have a difference of 4 grams per left bank and right bank. So a lot more balanced in the engine. So I think what I want to do here is maybe swap position 2 and 3 to see if this value changes a little bit in terms of which one's flowing more, and see if it's the fuel metering unit or see if it's the injectors. And if it's the injectors, then I'll change number 2 out. And even though that injector was new, it's so much lower than all the others. So I'll do the swap on the injectors and report back. Alright, so here we have the bottle test again for fuel flow. Since the last video. This is the first time I pulled the bottles out and put them on the bench here like this since the last video, but it's actually been I've been into the engine twice to change injectors because I did what I said there at the end of the last video, where looking at my numbers, I wanted to swap position 2 and 3 to see if the values would change. But actually what I did is I took 2 and 3 out and I put in my last 2 new injectors to see how they would flow. And when you do that, of course, then you got to do a full fuel flow test to bleed the air out, and then you get incorrect readings. So bleed the air out, empty the bottles, dump the fuel back in the tank, set it back up again, do it again. I also tried 2 different settings on my primary pressure regulator with different springs and bushing shims, but I'm still at my same around 69 psi, so that didn't fix that. But anyways, back to the injectors. So I changed 2 and 3, and when I did that the first time, the new injector actually for cylinder 2 was terrible. It barely flowed any fuel. So I took that out, and I actually took, so from the last time to this time, and these results, which here I'll give you a shot. So injector 3 is brand new, never been used before, and number 2 is actually the prior number 3. So I'm pretty happy with these results. These are all pretty even now in the bottles, but the weight test will tell. So in grams, these are my new values. 58, 58.5, 16.5, 57.5, 58.5. So they're all pretty close now. They're you know, within 3 grams of each other roughly. And if I add up the left bank, I get 177, and the right bank 174.5. So difference of 3.5, which is pretty good. 2.5 actually. So that's injector 2 now is the former number 3, that one, and injector 3 was a new one. So that's flowing consistently. So I'm going to call that done and put the injectors back on the car and see how she runs.